Hello, my name is Rich Howard, and this project that we're going to use the CNC machine for is creating custom ceiling tiles for a client. And this video is going to document the process of taking a look at what the client has requested, taking a look at the space in which they're going to be installed, and taking a look at something that the client has picked out, except they want a small little modification to it, something a little less complex than what's there. And we're going to do this out of 3/4 inch MDF. We're going to route these, what will be these suspended ceiling tiles. Let me show you so that you're sure of what I'm discussing. And I have one here, just a very typical suspended ceiling tile, basically a 2x2 square. They're about a 1/2 inch thick or so. Actually, I don't know how thick it is, but let's just measure that now. What the client's attempting to do is to get a little more depth in the ceiling. Yeah, this material is 0.601. It's almost 5/8 of an inch. So what we're going to put up there is going to be marginally thicker, but won't be very heavy because we're going to create a bunch of pocket tool paths where we're going to step to increase the depth of the material. Anyway, let's switch to the screen view. Let's take a closer look at what the client's working with, and let's take a closer look at what they would like. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Here is the ceiling that's being worked on. There's a mixture of LED lights along with original fluorescents. These are all going to be replaced, and we'll take an after picture. But these are the tiles that we're going to replace in here. And here is a close-up of what the tile, well, here's what the tile looks like. There's a close-up of the original. So not a lot of architectural character there. This is what's going to end up being a showroom display area for retail business. Now let's take a look at what the client has asked that we take a look at, except they kind of want it modified where you've got this stepping sort of procedure here, but not any round over work or not any V carving. It's just going to be geometrically uh, square. There's not going to be bevels or V's. Everything will be at 90-degree angles. And we're going to step that. We're going to take a look at what the client would like to have. So what we're going to do first is prototype a basic idea and then create a sample for client approval, and then make any changes that are necessary. And upon receipt of a final approved tile design, we're going to go to production and make about 120 of these or so. So let's get on with the tool pathing aspect.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video.
Let's move on to the rest of the video. Okay, let's start with a new sheet setup here. And we're going to literally start with a new sheet. So we're going to define our work piece size, and I know that it's 97 by 49. And our material thickness is 0.759. So it's supposed to be 3/4 inch. And the material is actually measuring with the caliper 0.759. And knowing that material thickness for me is very important because I don't want to breach through the other side. And I'm going to set my Z0 position off the material surface. And that's because I would likely count on a small amount of variation of the thickness of the MDF. But looking at the surface of the material, I want it to appear to be the same depth on every cut. And I really don't care ultimately how much of the backside thickness that you're never going to see. And what I mean by that is, if we're going to have a ceiling panel like this, and we're going to stair step some sort of pattern in here, and who knows, maybe it'll be like this. Not really sure yet, but we're going to discover that. I don't really care how much of this we can't detect what this dimension is. What I care about is how deep this is, how deep this is, how deep this is, and how deep that is. Don't care about the rest really. So that's why I'm going to Z0, I'm going to reference off of the top of the workpiece or the material surface. My datum is going to be in the lower left-hand corner. And for me, the word datum is a bit of an unusual word. It's not one that I use often. So let's just simply define datum. A fixed starting point of a scale or operation. An accurate datum is formed by which other machining operations can be carried out. I think of it as a point of reference. It does seem to me that a term that I don't use ever, but applies now that I know what it means. The modeling resolution will leave it very high. I'm going to double check this. My X is 97. My Y is 49. My material thickness in inches, material surface, material settings, uh, and single-sided. I've not explored double-sided just yet because I've not done anything double-sided yet. So let's click OK to that. Now, the way that I was taught was to use guidelines, lots of guidelines. And guidelines are great because it allows you to initiate your tool path drawing. So, now I've got to really think about what I want to do. The existing panel is 23 and 13/16 by 23 and 13/16. Now that's really interesting because I've got basically an 8-foot by 4-foot sheet. So my hope is I'm going to get 4 on the X and 2 on the Y. That's what I'd really like to accomplish. But I still want to be able to run a profile around the entire outside so I get a clean, so I know that I'm getting a squared outside workpiece. So I'm probably going to give me some guidelines for a profile, probably for an outside profile. And maybe what I'll do when I start the work is, let's just explore. So I'm going to bring a guideline out, and I want it to be in the position of 0.1875, apply. So what that has done is it's given me a guideline 3/16 off of the edge of my 49 inch. And that is indeed what I want because this is going to end up being a tool path. Now, when you grab a guideline, all you do is mouse click over here and drag. So I'm going to drag another guideline out here and I'm going to right mouse click. I'm going to right mouse click over the guideline and it pulls up this menu. I'm going to give it a new position of 96.8125. That should be 96 and 13/16 because I want 3/16 off the edge and apply, and it moved that over ever so slightly. So now what I'm going to do is drag a guideline from the top down. I'm going to right mouse button click. I'm going to give it a new position, apply. Now I'm going to do that yet again. I'm going to show you what's down here at some point, how to more easily create guidelines. Go to 49. I'm going to go to 48.8125 and click apply. So now what I've got here ultimately is going to be a tool path that I can run the bit on the outside of the material. And I would be running it on the right side of the material, but we'll get to that. So that's going to give me a true rectangle. From here, I'm basically going to be able to create another guideline. So let's pull a guideline. Actually, no, let's do this. Right mouse button, click that first guideline on the X because you know it's in the right place. You click relative to guide 23.8125. Yeah, let's just make sure. And then click create new guide. Close. Now it's given me a new guide. Forgive me, I want to be sure of something. 1 divided by 16 times 13.8125. Okay, I've been doing that for decades, knowing what that is, but I wanted to double check. So now what we've done is we've given us another guideline, 23 and 13/16 up. I'm going to go to this guideline, relative. I'm going to make this one negative 23 and 13/16 to go down, close. Okay, that looks great. Now I wonder what the distance is between these two guidelines, because I'll have to run a toolpath through there. And I can just get an idea of that with my little measuring tool. And over on the right, it says it's 1 inch. Okay, so that's perfect for what I want. It really is. All right, now, let's do it on the right. On this guideline, relative to new position, relative to position 23 and 13/16. Create new guide. Awesome. Now, what I'm unsure of, because I'm not pulling out my calculator and doing the math, which I just simply will, I don't know, I want to be sure of how much room I'm going to have after I draw all these out. So I've got my calculator, and I've got 97 minus 3/8, because 3/8 is twice of 3/16. It's 20, pardon me, it's 96 and 5/8. 96 and 5/8 divided by 23.8125 gives me 4.05. Now that's trouble. That's trouble. Because I'm not going to get enough of them in the width to get 8. I'm not going to get, because I've only got 0.05 inch divided by 3. So that's no bueno. So what I'll do is give me a new guide 1 inch over. Give me a new one 23 and 13/16 relative. Okay, give me a new one relative 1 inch, create new guide. Give me another one relative 23 and 13/16, close. Give me a new one relative 1. Now give me a new one relative 23 and 13/16. Yeah, yeah. So you can see what happened there. It put that guide all the way out here. So I don't have enough tool length. Well, I don't have enough tool length to get them all created. Now, what's okay, and when you want to get rid of the guide, you just slide it back over and it goes away. What's okay about this, though, is I'm going to need some unusual sized pieces. So this scrap that's going to be left over, I'm going to be able to use that material because I will have pieces that won't be the full width. I know I've got some outside corners, some weird size pieces. So at this point, we can get rid of this guide. These guides could stay. And now I've got a reference for an outside perimeter cut. Actually, we can get rid of that guide too, because this will be our outside. And I'm going to leave 1 inch between these. I mean, I wouldn't have gotten there anyway. I'm just making it 1 inch because this gap is 1 inch. We would never have gotten to where we need to be. I don't have a thin enough bit to go through the material, a small enough diameter. So at this point, we've got a profile toolpath on the outside. We've got profile toolpath, or at least guidelines for them, on each of the 6 tiles. And at this point, I could just change the material setup to be smaller. I could literally just change that 97 to, whatever. And that's going to basically increase my workspace area so it looks larger. 74. Yeah. I mean, it looks nicer now. At least it looks more symmetrical. It doesn't really matter because we know that there's going to be piece over here. I'm just excluding it from the drawing because our datum is down here, our lower left-hand corner. So at this point, we could create a toolpath for profiling the outside of the entire sheet and then profile cutting the 6 individual pieces that I'm going to yield. Before I do that, I'm going to add some additional guidelines to give me the idea of what a toolpath would actually look like. So at this point, we need to make a decision in terms of what we want it to look like is just simply the bottom line.
If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video.
I'm just staring at this in cross section. I have AutoCAD on here. I should just do it in AutoCAD. Not extremely proficient in AutoCAD, but enough to be able to draw some lines. So let's draw a line. I want to set up my grid to what I like. So I've got my grid set up to a 16th of an inch, and I've got 4 lines. The major lines are a quantity of 4. So 4 small lines make 1 major line, make 1/4 inch. I may change that because I'm not really sure of what increment I'm going to want to create the stepping cuts on the panels just yet. But nonetheless, this works. And the snap I'm going to set also to point to 1/16 of an inch. Okay, so yeah, yeah. You can't really see the lines, but this is a 16th of an inch here. That's an eighth. That's 3/16. That's a quarter. Now, because we have 0.759, I've got to think about how much um, depth I want to have left over. Here's our panel. What sort of reveal should we have? I'm going to say we're going to start with 1.5 inches, and then we're going to literally do stair stepping like this is what we're going to do. And the question becomes is should there be opposite stair stepping over here? I'm going to say no because the client's going for depth. So I think what we'll draw is going to be something that, and this is just awful freehand, but rather than watching me beleaguer it in AutoCAD first, that's the concept we're going to go for. That's roughly 3/4. This, we're going to go with this at being 1.5 inches. And then we've got to decide how deep each of these are going to be. So if they're going to be quirks, basically, is what they are. Maybe 3/16. And having a calculator handy is necessary, in my opinion. I mean, AutoCAD's got it there. I'm just doing it. Yeah, so if we took 0.759, and we subtracted 0.5625916. So 0.759 minus 0.5625, that's going to leave us with 3/16, basically. So 3/16, 3/16, 3/16, 3/16. This we're going to probably have to play with in terms of what to leave that, because I don't actually know the, well, actually, let's just figure out what it is and what I mean by that. We know it's 23 and 13/16 square, but what's the clear opening? So let's determine what that is. So I've measured the clear opening, and it's 23 and 3/16 by 23 and 3/16. Well, 23 and 9/16 minus 23 and 3/16 is, yeah, 5/8, 0.625. So if we divide that by 2, it's going to be 5/16 of the panel itself that you're not going to see. So you've got your T track. This is going to be 5/16 from the edge of the panel to here. So if we're going to make that 23 and 13/16, and we're going to lose 5/16, the question becomes is how much exposed room do we want here? And I'm going to say, let's make this dimension double what this is. So if this is going to be 3/16, then I'm going to want this dimension at 3/8. Okay, so we're going to need this dimension, the edge of the panel to the first cut, to be 5/16 plus 3/8, because I want 3/8 exposed, 3/8 here, 3/8 here. So 6, so that's 11/16. So the edge of the panel to this first cut is going to be 11/16 here to here. Then 3/8, 3/8, 3/16, 3/16, 3/16. So let's get an idea of what that looks like scaled out. So we're going to draw a line. We're going to start at the origin because that's just easy. And we're going to come over 0.6875. Enter. Yeah, that's good. Then we're going to go, we said 3/16. Then we want 3/8. Then we want 3/16. Then we want 3/8. Then we want 3/16. Now, let's do some quick math here because I want it to look scale. 0.6875 plus 0.75, because that 0.75 is double 3/8. So that's 1 and 7/16. So 23 and 13/16 minus 1 and 7/16 minus 1 and 7/16, because you'll need 1 and 7/16 on the other side. So that leaves us at 20 and 15/16. I could just 20.9375 right there, hit enter. Okay. Now we want to come down 3/16 over 3/8, down 3/16 over 3/8. One more time, I think. Yeah, 3/16, then 11/16. Then we're going to come basically to 0.75. We're not going to worry about the 9 thousandths of an inch. Over to our origin. 23 and 13/16, and voila. So that's what our panel is going to look like. Now what I'll do is take the origin, just move it out of the way. And that's what a profile of this panel is going to look like. The client's going for depth. So this is what we're going to create. And this is what we're going to take a look at and see what it looks like in the ceiling. And that's just what we're going to do. So I plan on just running a pocket tool path. I have a 1 3/8 diameter T-slotting bit, which works really well as a surfacing bit as well. And I plan to use that for this because it's wide. And I thought, well, I'll just order a wider bit so I could do this in less passes. But at the end of the day, I'm going to turn on the dust collector and make sure the tool pathing works, and then walk away and do other work because I am going to be doing, all of these at once. So now we have an idea of what our profile is going to look like. Here's a freehand sketch, something a little more exotic, or at least something to scale. And now I'm going to draw these guidelines, and I'm going to create tool paths based on them, is what I'm going to do. So let's start doing it.